is multiplied with the same binomial a plus b, then what we will have a special in this binomial into binomial, that we can say what will we basically extract of doing the same binomial with the binomial while doing the product. So we will be doing this with the help of the same property we have used here, that is distributive property, like a into c plus d and plus b into again c plus d. So in the similar pattern, if we do it, I will be getting a into a plus b plus b into a plus b again. So you will be having finally a square plus ab plus ba into, that is ba plus b square, b into b square. So these two are like terms. So we have a square plus ab plus ba. Ab plus ba means we have ab plus ab, so it will be 2ab. So we will have 2ab here and plus b square. So finally we have a special type of answer here, which can somehow, if we learn, if we remind it, if we remember it, that once we have two binomials with positive sign, and the same binomials, two same binomials are multiplied with each other, and if we try to remember it, then the answer will be a square plus 2ab plus b square. So if we remember this particular binomial into binomial, then we call it as identity. Why identity? Why do we call it as identity? You see, if this a plus b and a plus b is multiplied and answer is remembered, then this type of pattern can be used in certain questions. Say 2 plus say y into again 2 plus y. So we can remember it and apply it this particular which is known as identity. We can apply it here in this question. So fix them these two as a and y as b. So if we try to assemble all the terms in connection with the identity we have called it, then we will write here as 2 square plus 2 multiply a means 2, this is a, and this one is b. The 2 into a means 2 and b means y, plus b square means y square. So we will be getting this the answer, more precise answer, and the performing this same the binomial into binomial is little bit easy thing for us, right? So this is 4 plus 2 into 2, 4y plus y square. So finally we will have easy answer here, immediate answer here, and no like terms, unlike terms problem. All three terms are unlike terms, and you will get the swift answer here. So this is your identity number 1 with positive sign. This is a plus b into a plus b when multiplied, but same binomials with positive sign, you will be getting a square plus 2ab plus b square. So remember it and apply it in certain questions. You will be getting the swift answers, quick answers, and no need of assembling the like terms and unlike terms and all these. So you will be getting immediate answers here. So this is the simple method of doing identity, because the same thing will be applied in all the questions. So that is why it is known as identity. So your identity number 1 is a plus b into a plus b. You can rewrite it as a plus b into a plus b can be written as a plus b whole square. A plus b whole square. What is x into x? This is x square. What is a into a? This is a square. So this is what is m plus n into m plus n? This is m plus n whole square. No need to worry about it. So what's your answer is? Your answer is a square, according to the identity, a square plus 2ab plus b square. If we have m plus n whole square, then your answer is m square. Remember it, m square first term plus 2 into multiplication of first and second plus second term n square. Easy. Another one we have, what if we have a negative sign b and again multiplied with the same binomial a negative sign b? So this can be rewritten as a minus b whole square. No problem with it. I have told you earlier. This is your identity number 2. Identity number 2. Identity number 1 I have told you. In the similar pattern, identity number 2 it is. So by distributing a minus b and a minus b, a into a minus b into a minus b, I will be getting a square minus ab minus b into a minus of b into a, ab or ba, whatever, this is ab again, and minus of minus, minus into minus is plus b square. So you will be having a square, these two are similar terms, this is minus of 2ab plus b square. So if we somehow remember it, then we will be having a simple answer as a square minus 2ab plus b square. So previous identity was a plus b whole square, that was a square minus plus 2ab and plus b square. So these two are little bit same. Here we have negative sign 2ab and here we have positive sign 2ab. So once we apply this identity to the questions, say x minus 3 into x minus 3, say we can rewrite it as x minus 3 whole square, right? X minus 3 whole square, that can be reduced to, according to the identity here, x square minus sign 2 multiplication, a means x, b means 3 plus 3 square. So this is your x square minus 3 2s are 6, x plus 3 square, that is 9. So this will be your answer. Remember one thing, few students ever ask that why it is 3 when it is minus 3. So when we are saying that this is a, when this is b, we are taking a and b independent, so we are not talking about this minus sign. So this minus sign in between here is basically a minus sign will resemble to minus sign. So x minus 3, a minus b. So what is x? X is equal to a. What is 3? 3 is equal to b. Look, 3 is equal to b. Minus 3 is equal to minus b. So minus is gone. 3 is equal to b. Simple. 3 is equal to b. So whenever I am writing b to a b, whenever I am talking about b, write simply 3, not minus 3. So here plus sign, because of this plus sign, all you have to do is just to copy your identity. So this is the reason this is known as identity. You have to copy it in the questions. No need to worry about the negative sign in identity number 2. Make sure no need to worry about, just put minus sign here. That's all. All things, other things are a little bit easy. Identity number 3. What if we have a plus b and then a minus b? So what is it called? A binomial having positive sign in between and another binomial having negative sign. These two basically are different binomials. There is a term used here, conjugate of each other. I will talk about it in the later part, but at the very first look at it, by distributing it With the help of the previous ideas, I have given you a, start with a and multiply it with a minus b, then start with plus sign b and again multiply it with a minus b. All in all, you will be having a square minus ab and b into a plus sign, this is ab plus minus of b square. So these two will cancel out, you will be having a square minus b square. So this is something very interesting answer we have concluded here. This is a minus b into a plus b, a minus b I have taken here. A minus b, a plus b is a square minus b square. This is your identity number 3. Remember it. Even if you are, you can interchange these two, no problem with it. A minus b, write a minus b first and a plus b second. You will get same answer, a square minus b square. No problem with the distributive properties. In case of a into b, it is b into a, no problem with it. So the final answer is a little bit easy answer, and you can copy this answer to all the questions, resemble the questions easily. No problem of mixing the like terms and unlike terms, as I have told you. So how do we operate? How do we put this identity into the questions? Say x plus 3 and x minus 3 if we have, then we will copy this identity as a square. So mention this is a square, this is a, and this is your b. Don't bother about plus and minus, right? A is x and b is 3. So this is your x square minus 3 square. So final answer is x square minus, rewrite it as in a simplified format, x square minus 9. So all these three identities are little bit easy, and these identities will make a few questions more easy. No, I have told you, nothing like resembling the like term. This is your identity number 4. The first term of the first binomial binomial is x, and the first term of the second binomial is again x. So other terms are different terms. If we have this kind of pattern, then we simply multiply it with the distributive property, and we will be getting it here as x square plus bx plus ax plus a into b, that is ab, is equal to x square plus x is common into a plus b, b plus a is the same thing, right? So this is ab. So this is your pattern. If you try to remember this one, the similar type of questions will copy this formula and will give you answers in 2 lines, right? So that is why it is known as identity, and this is our identity number 4. So how do we operate when we have negative sign in the negative sign somewhere inside? So if we have negative sign, negative of a into x plus b, if we have any of the negative sign, just copy the negative sign, copy here negative sign and put here negative sign. You will be getting x square plus, don't rewrite it as negative sign, this is plus sign and bracket start minus a plus b and x plus negative sign a into b. That's all, simple, easy, no need to worry about it. If we have both of the negative signs, minus a and x minus b, then we will write it as x square plus bracket start minus of a minus of b into x plus negative of a into negative of b. No problem with it. So just multiply these two, simplify this one and you will be getting answer. So no need to worry about it. So this is your identity number 4. It will create few questions of this type, this category, and answers will be a little bit easy. So this is what you have to remember. X plus a, x plus b is equal to x square plus a plus b into x outside, right? Binomial into monomial plus ab. So this is your identity number 4. terms or unlike terms finding out, and nothing to do about it. Just copy the identity, resemble the terms and copy the identity. That's all. You will be getting the answer. Let us start exercise 9.5, use of algebraic identities. I will be telling you when and how these identities being used into the questions. The first question is x plus 3 into x plus 3. So what kind of multiplication it is? Binomial into binomial having the same binomials, right? So this is a type, a category of a plus b and a plus b in multiplications, which can be written as, if you remember, this can be written as a plus b whole square first, then its answer is a square plus 2ab plus b square. If you remember it, you just have to remember this one, right? A plus b into a plus b is equal to a square plus 2ab plus b square. So if I write here a plus b whole square first, which is equal to a square plus 2ab plus b square. Now just put the question and copy this identity into the question. So this is x plus 3, this is equal to x plus 3 whole square, isn't it? X plus 3 whole square. So this x plus 3 whole square is equal to, find out your a is x here. So this is x square plus, just copy it, 2, right here 2, multiplication, here is multiplication sign, a means x, and again multiplication sign, b is 3, and this is equal to b squares mean 3 square, right? 3 square. So this is your x square plus 3 2s are 6x plus 3 square is 9. So this is your answer. Similarly I can apply this in all the segments of, in all other questions. If I take another example, of the identity part in question number 1, if I take the third part, 1 2 3 third part, which says multiplications of 2a minus 7 into 2a minus 7. So look at it, this is again same binomials with negative sign. This is 2a minus 7 whole square. If you remember it, if you remember the identity a minus b whole square, that was a square with negative sign 2ab and plus b square. If you have any remembrance of this one, performing this one multiplication is a little bit easy, I have told you. So just copy this question here, 2a minus 7 whole square. Now this a is 2a for me. Remember it, a cannot be equal to 2a, but in case of resembling the terms, this a is resembling with 2a, this b is resembling with 7, not minus 7. This is minus b and this b is resembling with 7. So I am just copying it. A, whenever I have been given a, I am writing a 2a whole square. Why whole square? This is a in 2 into a. So if I write a 2a square, it will be incorrect. This a square will not go to 2. Whenever I am not putting the bracket here, this 2 will be taken, this power 2 will be taken by a. So you have to put here bracket, remember it, minus 2 multiply 2a multiply 7. So your b is 7. Resemble it, remember it, copy. I have told you b is 7, a is 2a. A is not equal to 2a, but for me this first term is 2a. This a for me is 2a. So likewise I will be writing here as 7 square. Finally your answer is 2 will take up 2 square, that will give you 4a square. So remember it, 2a square could be wrong. What I have to do is 2a whole square. that will be equal to 4a square, right? So this is what I have done here. Minus sign, 2 into 2 is 4, 4 7s are 28. 28a plus 7, 7 square. 7 square is equal to 7 into 7. Sometimes students are writing here 7 2s are 14. So this is not 14, this is 49. So this is 49. So no similar terms. This is your answer. Easy. Next question I'm taking is question number 1, part number 6. All other questions are easy. Question number 6, part number 6, question number 1. Exercise is 9.5. Exercise 9.5. Yeah, this one. Exercise 9.5. Question number, part number 6. So this is a square plus b square, a square plus b square into minus a square plus b square. So there's nothing wrong with it. We just want to resemble these two binomials with any of our identities. So if I try to rewrite this binomial into binomial as, look, this is minus a square, so we don't have any idea what to do with this minus. But if we rearrange these two, and rewrite it as a square plus b square and b square minus a square, there is no problem with it. So right, so with positive sign we can also rearrange these two also, right? So finally we have b square plus a square and a square, this is a b square minus a square. Now looking into it, this question is basically resembling identity number 3. What was it? A minus b, a plus b into a minus b, that was a square minus b square, giving answer. So this question is actually resembling this one, right? So finally I will be doing, what is a? A is b square. Look, this is first term, right? So my first term is b square, b square, b square. My second term is a square, and second term is b, b. So if I am copying this one identity into here, I will be getting, just a bit, I will be getting answer as b square whole square minus a square whole square. So that will give me an answer as b raised to power 4 minus a raised to power 4, right? It's easy. This is question number 1, part number 8, minus a plus c minus a plus c. If I rewrite these two binomials, then c and minus a are interchangeable here. You can say 2 minus 3 if we have, then I can write is equal to minus 3 plus 2. There is no problem with it. Minus 3 plus 2. In the same way, if I have minus a plus c, then I can write c minus a. So there is no problem with it. So by rearranging these two, if I look carefully, these two binomials in multiplication will give you an idea of identity number 2. What is it? A minus b into a minus b. So what was answer? A square minus 2ab plus b square, right? Plus b square. So similarly, if I copy this formula, a minus b whole square is equal to a square minus 2ab plus b square, I should write here we know that, right? If I copy this one is my question, c minus a into c minus a, which is c minus a whole square. If I copy this one, c minus a, c minus a whole square. My answer after copying the identity will be c square resemble these two, right? Minus 2 a c or ca. What is it? c a plus a square. Don't put negative sign here. So this is your answer, right? It's easy one. Another question we have, question number 9, subpart 9. This is x upon 2 plus 3y upon 4 into x upon 2 plus 3y upon 4. So this question of binomial into binomial reminds me identity number 1, isn't it? Identity number 1. So this can be rewritten as x upon 2 plus 3y upon 4 whole square, right? So if I remember, a plus b whole square is equal to a square plus 2ab plus b square. I am just trying to write identity every time the identity which the question actually is resembling. I am writing every time identity, right? You just try to put this identity first. If you recognize the question which identity it is belonging, then write the identity first, then copy the question below and write here 3y upon 4 whole square is equal to x upon 2 whole square plus 2 into a means x upon 2 and b means 3y upon 4 plus b square is 3y upon 4 whole square. Note down whole square means covering all the components of any term. So this is equal to x square upon 4. You can open this term, open this bracket, and 2 is cancelled with 2, and this is 3xy plus 3xy upon 4 plus 3 square is 9, taking its own power. 3 square is 9, y square is again y square, that's all. 4 square is 16. So no need to take up the LCM and doing other, you can say, further reduce it. Just remember this will be your answer. No need to take up the LCM and doing all this. All these terms are unlike terms. No need of taking. There is nothing about taking of LCM and doing else. All these terms are unlike terms. There is nothing in it by taking. You will not go anywhere. So just this is your answer. Question number 2, it says use this identity x plus a into x plus b is equal to x square plus a plus b whole into x outside plus ab. This was the identity number 4 I have told you previously. So this identity has to be used in the question number 2. The first question is x plus I should write here first question as x plus 3 into x plus 7. So just copy this, resemble all these terms. X is resembling with x square we have, bracket start. A, what is a is 3, so this is 3 plus what is b is 7. So what is x is x plus ab means 3 into 7. So your answer is just little bit of multiplication and addition here. So your answer rewritten as x square plus 10x plus 7 3s are 21. That's all. This is your answer. Question number, part number 2. Part number 2 says 4x plus 5 into 4x plus 1. Similarly, 4x is my first term, 4x whole square. Remember, both the components of the first term will take up the power, so that is why the bracket plus bracket start. What is a here? What is a? X plus a is 5 plus what is b is 1. So what is multiplication? Multiplied by x. X means 4x. So for me it is 4x plus what is last term? This is a into b, 5 into 1. Your answer is 16. Just rewrite it. Is 16x square plus 5 plus 1, 6 into 4, 6 into 4x. I will create another line here. So this is 5 ones are 5. So again rewrite is at 16x square plus 6 fours are 24 x plus 5. So all these different unlike terms, and this is your answer. This is question number part number 2. Part number 3 says with negative sign 1 2 3. First 4x minus 5 into 4x minus 1. So how do we do this negative sign? Remember 4x plus minus 5, 4x minus 1. So this is 4x whole square. Put plus sign here. Start with bracket. Write here a. What is a? What is a? For this a is minus 5. So a is minus 5. Plus what is b? B is minus 1. B is minus 1. So small bracket and the larger bracket you can incorporate here like this. So what is outside? Into 4x. What is next? Plus sign. Remember it. What is a? A is minus 5. What is b? B is minus 1. That's all. Easy. So just rearrange all things. This is 16x square plus minus 5 and minus 1 is minus 6. Put bracket again into 4x. And what is next? Minus sign multiplied minus sign is plus sign. 5 ones are 5. Just rearrange them. 16x square plus into 5 is plus minus is minus, 6 into 4 is 24. 6 into 4 is 24 x plus 5. So this is your answer. That's all. Easy thing. So these 3 questions. Let's do another question. Say question number part number 6 कर देता हूँ. Part number 6. 2a square plus 9 into 2a square plus 5. So this has to be done with the identity x plus a into x plus b, which is equal to x square plus a plus b into x plus ab. So just copy this question just below the identity 2a square plus 5. So your answer will be copying all the terms. Resemble x is 2a square. So this is 2a square. Remember 2a square is not x square, it is x now. And putting here square is this one, right? Look at it. So plus bracket start. What is a? A is 9 plus what is b? B is 5. And what is x? X is into 2a square. So what is a? 9. What is b? 5. Easy. So this is your 2 square. This square will not go to 2. This 2 will take up this one. 2 square is 4. A square square. This is a square square. What is a square square? This is a raised to power 4. So a raised to power 4 here plus 9 plus 4, right? 14 into 2a square plus 45. This will be rearranged to the final conclusion as 14 into 2, 28, a square plus 45. A4, a square without a, all unlike terms, and this is your answer. This is how we do these questions. Question number 3. Use suitable identity. What is written? Find the following squares by using the identity. The first question is b minus 7 whole square. So this will immediately remember you the second identity a minus b whole square, right? A minus b whole square. This is a square minus 2ab plus b square, right? So just copy the question b minus 7 below the identity and start solution, right? Start solution. This is equal to, b for me is a, so this is b square minus 2 into b square minus 2 into b into 7 plus 7 square. No need to copy the negative sign here. So this identity will take up the negative sign responsibility here. Don't worry about it, this negative sign. So once I am talking about b, I am talking about 7. This is b, this is 7, right? So whenever I am talking about b, I am writing 7. So this is equal to b square minus 7 to the 14b plus 49 is your answer. Easy thing. If we take up a few more examples of this question number 3, let us do this question number 4. All other questions are similar questions, right? 2 by 3 m minus 2 by 3 m plus sign, sorry, 2 by 3 m plus 3 by 2 n whole square. So this is basically resembling identity number 1. So identity number 1 says a plus b whole square is equal to a square plus 2ab plus b square. So copying this question below the identity, 2 by 3 m plus 3 by 2 n whole square, you will be getting 2 by 3 m whole square plus 2 multiply 2 by 3 m multiply 3 by 2 n plus 3 by 2 n whole square. This will give you 2 square will take up 2 will take up square. 2 raised to power 2 is 4, 3 raised to power 2 is 9, m square is m square plus 2. This 2 will cancel out because of this multiplication sign. 3 will cancel out 3. So all you have is 2 m n plus 3 square is 9, 2 square is 4, n square in product. So this is your answer. Easy thing. Let us use all these identities into the different questions. In question number 4, which says simplify. So what we have to do in this question is to use these identities we have done. Identity number 1, 2, 3, 4 identities we have, and we have to use these identities into these questions. So the first one is a square minus b square whole square. So when I look into this question, the first component, it reminds me identity number 2 with negative sign, right? A minus b whole square is equal to a square minus 2ab plus b square. So if I write here a minus b identity, write identity first. A minus b whole square is equal to a square minus 2ab plus b square. So just copy this question. A square minus b square whole square is equal to, for me a is a square. So whenever I am writing a square here, this is not a square, but this is as a whole as a. So what I have to do is to put another square. So this one is actually this whole component, right? So this 2 is at here. So this is what I have to take the caution. This is 2 into a means a square for me, right? A square. And what is b? B is b square. And what is b square? B square means b square whole square. So your answer is a raised to power 4 minus 2 a square b square plus b raised to power 4, which is your final destiny. Let's take up the second question of exercise 9.5, question number 4, which says 2x plus 5 whole square minus 2x minus 5 whole square. So this question is basically the combination of two identities. This is identity number 1. If you remember, this is a plus b whole square, identity number 1, and identity number 2 is a minus b whole square. So this is identity number 2, right? So if I'm not bothering about it and I'm putting here negative sign and then starting the brackets, I will be writing the first identity component, a 2x plus 5 whole square, in the open format, that is a square plus 2ab plus b square, and this is a square minus 2ab plus b square. So if I take, this is 2x whole square plus 2 into 2x into 5 plus 5 square, then the negative sign, this one, and inside this is 2x whole square. So change this into the larger bracket, minus sign 2 into 2x into 5, and then plus sign 5 square. So these two are identity number 1 and identity number 2. That's all, simple. So this will give you 4x square plus 4 into 5 is 20 x plus 25, negative sign, bracket start, 4x square minus 20x plus 25, bracket close. So open this bracket, you will be getting 4x square plus 20x plus 25, negative sign 4x square, positive sign 20x, negative sign 25. No need to explain it. This negative will change all the signs of the second polynomial. So this will be 4x square and 4x square will cancel out, plus 25 and minus 25 will cancel out, and all you have is 20x plus 20x. Your final answer is 40x, right? This is your answer. These questions are same. In question number 4, I am performing the question number 6 or 7 for you. All other questions are same, right? So you can perform them easily. I'm just doing question number 6, part number 6 and part number 7. So I'm just doing part number 6, AB minus plus BC whole square and minus 2AB square C. So this is easy one. So just put here identity number 1. What is identity number 1? A plus B whole square is equal to A square plus 2AB plus B square, right? So this is AB whole square, just copying this, AB whole square plus 2 into AB into BC plus B square means BC whole square. So this is all about the identity number 1, minus 2AB whole square, AB square C is another term we have. So rearranging this is A square B square plus 2AB square C plus B square C square minus 2AB square C. So 2AB square C and minus 2AB square C will cancel out. You will be remained with A square B square plus B square C square as your final answer. Question number 5, part number 1. Use of all these identities in questions. This is 3 plus x, 3x plus 7 whole square minus 84 x is always equal to 3x minus 7 whole square. So what we have to do is to show that this is a problem in which it is written as show that the left hand term is equal to right hand term. So all I have to perform is the left hand side here and the right hand side here. So this is a kind of question in which we will perform left hand side and right hand side and try to check out whether the answers are same. So the left hand side is 3x plus 7 whole square minus 84x. Applying here identity number 1, a plus b whole square, if you remember. So I can write without putting identity now. Identity is little bit easy for you now, so I can just use here as 3x whole square plus, this is a square, plus 2ab plus b square. I am writing for you. So this is plus 2 into a is 3x, into b is 7, and plus 7 square, that is b square, minus 84x. So this can be rewritten as 9x square plus 9x square plus 3 2s are 6, 7 6 are 42x plus 49 minus 84. So 84x negative sign, 42 positive sign. These two are like terms. So all we have to do is to rewrite it as 9x square minus 84 plus 42, minus 84 x plus 42x will give you minus 42x. So this is minus of 42x plus 9. 49. So this is your left hand side. Now let us see what is there in the right hand side. This is 3x minus 7 whole square. By opening it with the identity a minus b whole square, which is equal to a square minus 2ab plus b square. So this is equal to 3x whole square minus 2 into 3x into 7 plus 7 square. So this will give you 9x square, 3 2s are 6, 7 are 42, minus of 42x, interesting, plus 49. So all these three terms are resembling with these three terms. So what do we have? Left hand side is equal to right hand side. So it is verified that the whole of the polynomial in left hand side is equal to the right hand side. So which proves that 3x plus 7 whole square minus 42x is equal to 3x minus 7 whole square. All other components in question number 5 are bit same, so nothing to worry about. I'm just doing for you is part number 5. Part number 5, a minus b into a plus b, a minus b into a plus b, plus b minus c into b plus c, plus c minus a into c plus a, right? So is equal to 0. I have to prove it. So this is left hand side, right hand side is 0. So left hand side I will be taking left hand side. Left hand side show that this whole term, this whole polynomial is equal to 0. So all I have to do is to perform left hand side. This one is identity number 3, a minus b into a plus b. So what is answer? A square minus b square. If you remember, all these three binomials are constituting identity number 3, this one. So by resembling all these and copying all these three with the identity part, I will be getting a square minus b square plus sign here, this one, and b minus c, b plus c is again b square minus c square. Again putting the same identity, copying it, c square minus a square, which must be equal to a square will cancel out a square, b square negative sign, b square positive sign, c square negative sign, c square positive sign is equal to 0. Easy one. So I can write here as hence proved. Hence proved. That's all. Number 6 says using identities evaluate. The first component is 71 whole square. So all we have to do is to apply algebraic identity for solving 71 whole square. 71 square is already known to us. 71 into 71, 1 ones are 1, 7 ones are 7. This is 7 ones are 7, and 4 7 7 49. So this is 1, 7 7 14, and this is 10, and this is 5 501 5041 will be your answer. But this is not the way we use here. We just try to understand of we just want to apply any of the identity, appropriate identity we want to apply for solving 71 whole square. Putting identities is sometimes making the calculations easy as well. So this is the first time we are using algebraic identities with the numbers. So don't worry about it, numbers can take up the identities as well, don't worry. So how do we perform? So first of all, try to write 71 whole square is equal to 70 plus 1. Take up any of idea, just try to resemble this question with the identity 70 plus 1 whole square. So what is it? A plus b whole square, that's all. So I will be doing a plus b whole square here, and answer will be a plus b whole square is a square plus 2ab plus b square. So all I have to do is to copy 70 plus 1, that is 71 whole square is equal to 70 square plus 2 into 70 into 1 plus 1 square. So your answer is 4900. If you are able to perform this, 70 into 70 is 4900 plus 7 2s are 14 into 0 into 10, that is 140 plus 1. So just do like 0 0 and 1. So right here 1, this is 4, no tens place here, 4 and 0, this is 4, simple. This is 9 and 1 10, and this is 4 and carry 1, so this is 5041. As your 71 and 71 we have done 5041, so this will be your answer. So this is how we apply algebraic identity into the multiplications. Similarly, you can perform 99 whole square as 100 minus 1 whole square, right? So use here identity a minus b whole square. So this is when this one can be done with the identity. This is 100 square minus 2 into 100 into 1 minus 1 square. If you remember, a square minus 2ab plus b square, right? So this is equal to 100 square is little bit easy. 100 square is 10,000 minus 2 into 100 into 1 is 200 minus 1. No, this plus 1, this is plus 1, remember it, this is b square, and these two are to be added. or 10,001 minus 200 will give you just to subtract 10,001 200 from 10,001, you will be getting 9,000. Just do it. 001 minus 200, this is 1, 10, this is 0, this is 10 to 8, this is 9. So all you have is 9801, 9801. Similarly, you can perform 102 whole square as 100 plus 2 whole square, putting identity a plus b whole square. You can do 998 whole square as 1000 minus 2 whole square, putting identity a minus b whole square. And you can do 5.2 whole square. Let me show you how we will perform with the decimal sign and using this these identities. So here is 5.2 whole square, which can be written as 5 plus 0.2 whole square. So identity is a plus b whole square, so I will be writing it as 5 square a square plus 2ab plus b square plus 2 into 5 into 0.2. So this is multiplication, right? Don't confuse it with the dot. Plus 0.2 square. So this will give you 25 plus 5 into 2 10, this is 10 multiply 0.2, so this will be 2, right? So 2 plus 0.04. if you are capable of doing 0.2 multiply 0.2, you will be getting 0.04. so your answer is 27 plus 0.04. Final answer is 27.04. Easy one. This is how we perform. Another one, 297 into 303. So this can be rewritten as 300 minus 3 into 300 plus 3. So what is this reminding you of? This is a minus b into a plus b, so which will give you a square minus b square. So finally you can take it as 300 whole square minus 3 square as answer. So rewriting it is 90,000 minus 9. So 90,000 minus 9 is 89,991, isn't it? Easy. The next one is similar thing, 78 into 82. I can rewrite it as 80 minus 2 into 80 plus 2. So similar thing, same pattern. The last one is 10.5 into 9.5. So which will be rewritten as 10 plus 0.5 into 10 minus 0.5. So will give you, I will perform it for you. This is 10 square minus 0.5 whole square. So the same identity will be used here. So this will give you 1000, 10 square is 100 minus my 0.5 square is 0.5 0.25 will give you answer as 100 minus 0.25 is 99.75, I believe, which will be your answer. This is question number 7. Identity number 3 in reverse order we have to use here. So first question is 51 whole square minus 49 whole square. So look how these identities make calculations bit easy. So in the reverse order, when we use this identity, as I will write here, the copying A is 51 and B is 49. So I will be writing it as for 51 minus 49. You can say 51 plus 49 I should write here, as I have written here plus sign, into 51 minus 49. So all we have is 51 and 49 adding up to 100. Here is product sign, multiplication, and these two will constitute 2. So this is 200. Simple answer, easy one. So here is multiplication, remember it, these two are added to 100, these two added to 2, subtracted 49 from 51, you will be getting 2. So 100 minus 200 into 2 is 200, that's all. So very doing this identity is creating a little bit easiness with the calculations, and all these questions, avoiding difficult calculations and putting the simple answers here. So if I perform another one for you, say fourth part, which is 12.1 whole square minus 7.9 whole square. So if I rewrite it as according to the identity, this is A 12.1 plus 7.9 into 12.1 minus 7.9. So all I have is equal to 12.1, 7.9 adding up to 0, 7 to 9 and 1, 10. So this is 10 into 12.1 minus 7.9. So 11 minus 9 is 2.1, 11 minus 7 is 4, so this is 4.2. So my answer is 10 into 4.2, which is little bit easy, 42. That's all, easy. So this is how we perform these identities in the questions and making the calculations easy. The last question of the exercise is question number 8, and it says use this x plus a into x plus b is equal to x square plus a plus b into x plus ab. Use this identity and find 103 into 104. Look at it, 103 and 104 is actually not resembling with this identity, but we have to rearrange these terms, and I will write 100 plus 3 and 100 plus 4. So now it is resembling with this identity, and copying the terms, I will write 100 square plus bracket start 3 plus 4 into 100 outside plus 3 into 4, right? So this is equal to 10,000 plus 3 4s are 12 into 100, 12 into 100, I will rearrange it, and 3 4s are 12, so this is equal to 10,000 plus 1200 plus 12. So this one is 2 1 0 0 1 2 0 2 1 0 1, and last one is 1. So this is 11,212 is your answer. So this is how we perform. Let me do another one for you, the last component, fourth part, that is 7 point, no, this is 9.7 into 9.8. if I rearrange and reassemble, I will be getting 10 minus 0.3 and 10 minus 0.2. so copying the identity, I will be writing 10 square plus bracket start, larger bracket, in fact because of this negative sign, minus 0.3 plus minus of 0.2 bracket close, larger bracket close, and then write outside as 10 because of this x, plus minus of 0.3 into minus of 0.2 into, that is why we are putting brackets here. So this is 100 plus minus 0.3 minus 0.2 will constitute to minus of 0.5, no multiplication. So these are two adding up to minus of 0.5 into 10, and negative sign, multiplication negative sign will give you plus sign. 0.3 and 0.2, 0.3 0.2 multiplied and will give you 6012 0. So 0.06, this will be 100, negative sign, multiply these two, 5 plus 0.06, so this is equal to 95, you can write, plus 0.06. so this your final answer is 95.06. that's all, this is your answer.